Hi, let's talk about consistent hashing. But to understand consistent hashing better, let's first talk about hashing. So, hashing is the process of converting a given value into another smaller value for a constant retrieval time. So, what we do is we take a plain text, we use a hash function to convert this plain text into a hashed value. So, when hashing is useful, it is useful when you want to retrieve an item in a faster way. For an example, a hash table. So let's take a simple example to understand this better. Let's say you have multiple keys present and you want to store those keys on a particular location in your hash table. So what we do is we take a key, we use hash function to find out the hash location. So here we get for Rishabh, we get the hash function value as 3. So it is stored at the third position. Similarly for Ashish, it is stored at the 0th position. So this way we can use hash function to find the hash value. But this can also cause a hash collision. How? If you have multiple keys present and two different keys provide you the same hash value, then there can be a hash collision. Let's understand it with a detailed example. So let's say if you have 6 keys present and you only have 4 locations. So we have a fixed size window. So what we will do is for each key, we will first find a hash value, and then since the locations are fixed, we will perform a modulus with the size. For an example, let's take a key. So the key is Rishabh. When we perform a hash function, we might get value as 63. Let's assume the hash function is returning the hash value as 63. But we only have 4 locations present in our hash table. So what we do is we perform a modulus by the size. So the size is 4. So when we perform 63 modulus 4, the answer we get is 3. So that means Rishabh will get stored at the third location. Similarly, there might be other value Pearl which might return a similar hash value, and at the end it might also get stored at the third location. So again there is a hash collision that we are storing two different values at the same location. To overcome this, we can use different mechanism. One example, a simple example is to use a linked list at each place. So what we do is at each location we use a linked list. So in the linked list we store the key and value both, and then we can point to the next pointer, and the next pointer can again have the key and value. So that way we can store multiple key value pairs at a single location. Now let's think about distributed hashing. So when we are talking about hash table, we assume that that hash table is stored only on one server. But let's say that hash table is very large. It has like millions of location, it has like million size, and it cannot be stored in a single system. So what we do in a distributed system is we break that hash table and we store in a different systems. So we store the keys on different system so that our system is distributed in nature. So let's assume that in this hash location we have 5 keys. So the first 3 keys 0 1 2 we are storing on a system 1, but the remaining 2 we are storing on a system 2. So the size is 5. So how we calculate is if the key is Rishabh, the hash value we might get is 64 and the size is 5. So the final location for Rishabh to get stored is 4. We do 64 modulus 5, it will give us 4. So Rishabh gets stored on the fourth location. Now that is present in system 2. Now let's take a scenario that system 2 goes down for any reason. Now when system 2 goes down and we want to retrieve the key Rishabh again. So if we do a new calculation now, our key is Rishabh but our size is reduced to 3. So when we try to find out the final location, we do 64 modulus 3 and we get the location as 1. So we try to find the value at first location, but actually it was stored at the fourth location. So this does not give us the correct answer. Even the same thing happens if we add a new system because the size value will change. The size might change from 5 to 7. So again, when we try to calculate the value, it will give us the wrong location. So to overcome this, what we usually do is we remap all the keys. So whenever we remove a system or whenever we add a system, we remap all the keys so that we always get the correct output. But in this case, the worst case scenario we will have to remap all the possible keys present, which is not a good way. So to overcome this, we come to consistent hashing. Now in consistent hashing, we do not uh, map each key to a location. Instead, what we do is we hash the keys and we also hash the servers within the same range. So for example, if we have a range of 10,000, we use that 10,000 range to hash the keys as well as to hash the servers. Now assume we have only three servers present: server 1, server 2 and server 3. And we use a hash function to calculate the location of these servers. So when we use for server 1, we might get the location as 1243, for server 2 5634, and for server 3 59815. Now let's say we have three keys again: Rishabh, Nikhil and Ashish. And when we try to calculate the hash value of these keys, so the hash value can be different values. So let's again put these keys also on our ring. So for example, our key 1 is coming here, key 2 is coming here, and key 3 is coming here. If we consider that there is a range from 0 to 10,000 in this ring. Now, what we do in consistent hashing is we assume that each key that is coming should get mapped to its next greater value server. For example, if the key is 2456, it should get mapped to the next greater server. So next greater server here is 5634. So this key will get stored into this server. Similarly, key 2 will get stored in S3, which is 9815. Now key 1 value is 9927. So there is no next greater server. So another assumption we take is whenever we have a key which is higher than the server number, then we go back to the first server. So if we have exhausted the limit of the server digit, then the last key will again remap to the first server. That is why we have represented this in a ring. That is why we call it a hash ring. So a consistent hash ring where the last value will again get mapped to the first server if it is higher than the last server hash value. So how it is going to look like is key 3 will get mapped to server 2, key 2 will get mapped to server 3, and key 1 will get mapped to server 1. Now again we take an example where server 1 goes down. So if server 1 goes down, what we can simply do is we can only remap few keys. So we do not need to remap key 2 and key 3 because they will always be present in server 2 and server 3. We only need to remap key 1 here. So we'll remap key 1 to the next possible server. So the next possible server is server 2. Now let's assume that there are few more keys in between. There is key 5 and key 4 also present. So those keys will also get stored in server 2. But what this leads to? If you look here carefully, key 2 is present in server 3, but key 1, 3, 4, 5 are present in server 2. So is there a load balance? So the load is not balanced now because there might be many keys which will be present in server 2, but there might be fewer keys which will be present in server 3. So what is the solution to this? So to overcome this, what we do is we create a replica of each server. So we use multiple hash function to calculate server hash values. So earlier we only had server 2 hash value as 5634 using one hash function. So we'll use two more hash functions to calculate the replica server location on the ring. For example, the server 2 will present now on the three locations, similarly server 3 and similarly server 1. So how it is going to look like is, let's say this was our original server 1. It was present on 1234 location. Now we'll have a replica which is present on 3789 location, and we have another replica which is present at 8767 location. Similarly for server 2, original location is this. There is one replica location and there is second replica location. Similarly for server 3, the original location is this. There is one replica location here and another replica location here. Now how this thing helps? So let's assume that again server 1 goes down. So when server 1 will go down, all its replica will also go down. Now what will happen is we will again remap all the keys to the nearest server. So if there was server 1 present at this location and it went down, then we will remap server this particular key to server 3 because server 3's replica is present here. And this key will be mapped to this server, and again this key will be mapped to this server. Now how it helps is, since we have multiple replicas present for each server on different locations on the ring, if any of the server goes down, other servers replica will take those keys. So we will not actually put all the load onto only one server, we'll distribute the loads because the replica servers will take those keys in. So what happens in this case is only k by n number of keys are needed to be remapped when a server is added or removed. So k basically here is the number of total keys and n is the number of servers. So if we look here, even if server 1 went down, only few keys need to be remapped because we had replica present here for server 2. And if there was a key present here, then there's another server replica present here. So both of these keys now do not need to go to server 2 here, but one will again connect to server 2's replica and another will connect to server 3's replica. So in this way, the keys will get distributed properly. So that is the main advantage of using consistent hashing. And the main thing we need to remember is to use multiple replicas of the same server using different hash functions. So that is the basic about consistent hashing. It really helps if in cases where you're using Redis or meme cache, those systems actually use consistent hashing to store keys because they use distributed systems to store multiple keys across systems. So that is it. Thank you.